Hey guys, hope you are all doing good. In this video we have some exciting challenges for week 3. Do watch the video without skipping because I will be giving instructions to the particular question. If you don't follow those instructions then you will be awarded 0 marks for that question. Okay, some of the topics are covered in the YouTube videos and some of the topics are covered in live sessions. Okay, if you are interested in our course Matlab for Mechanical Engineers, you can fill the Google form link to which is given in the description. So let's start with the first question. Which of the following is or are false? If V is a vector, del dot V is equal to V dot del, where del is an operator. B. CFD is an independent technique, and the option C is if two vectors are orthogonal, then the dot product is 0. If you answer all the questions correctly, then you will be awarded full marks. In all other cases, you will be awarded 0 marks. Now let's move on to question number 2. Phi is equal to 3xy plus y square be a scalar function, then find grad of phi. Write all the steps associated with the problem while submitting the assignment. If you don't follow the instructions given, then you will be awarded 0 marks. Coming to the third question, let v is equal to 2x square y times I vector plus y square x times j vector be a vector function, then find the curl of v and divergence of v. And in this problem also you need to show all the steps associated with the problem. Okay, now let us move on to fourth question. In the fourth question you have to write a computer program to implement the following function given below and plot the results for t is equal to 0.2, 0.4, 0.5, 1 and 5 seconds. In this problem we have two variables, one is t and the other is y. In the previous assignments we have solved just for variable y. Okay, in this problem you have two variables. Now let us look at the pseudo code. Take y as an array of 40 elements between 0 and 0.04. Take t as an array of times, that is for time t is equal to 0.2, 0.4, 0.5, 1 and 5 seconds. And now you need to take three nested for loops. One is for a particular y and particular time, and the other is for particular time and for different y values, and this is for different times. After completion of calculation for a particular y, store those values. Best practice is to store the values of u for all the y's for a particular time in a row, meaning once the calculation is done, use u of k comma j is equal to value, where k is the index of time loop. After storing all the values, plot the first row of u using plot of u of 1 comma east comma y. First row of u will be on x axis and y will be on y axis. That is for time t is equal to 0.2, and using hold on command plot for different times, that is 0.4, 0.5, 1 and 5 seconds. Okay, this is how ideally your plot should look like. So this is for time t is equal to 0.2 and this is for time t is equal to 0.4. You'll get lines between black and blue for time 0.5, 1 and this is for t is equal to 5 seconds. You'll get a straight line. In the upcoming videos, we'll learn important concepts related to computational fluid dynamics, that is the substantial derivative and mass conservation equations. That's all for this week. Hope you guys liked it. If you did, like it, share it, and if you haven't subscribed to my channel yet, hit the subscribe button along with the notification bell. See you guys in the next week. Bye.